Hello friends, this video Sets Part 12 is brought to you by examfear.com. No more fear from exams. Before watching this video, you should have watched Sets Part 1 to Part 11. Now we'll read difference of sets. Difference of set is denoted by A minus B. So it is nothing but all the elements which are part of A but not part of B. A but not B. A intersection B is A but not B. A but not B. That is A minus B. For example, in this case, A is having 1, 2, 3, 4, 5, 6 and B is having 2, 4, 6, 8. And now we want to find A minus B. And also B minus A will find. To do this using normal approach, what we do, we subtract all the elements. Now I'm finding A minus B first. So I'll subtract all the elements of B from A. B is there. For example, B has 2, this guy is 2, so we'll subtract this. 4 is there in B, we'll subtract this from here. 6 is here, we'll subtract this. 8 is not there, so it won't be subtracted. Okay, we are doing A minus B. So in this case, we'll subtract all the elements of B from A. So 2, 4, 6, 8 is a common element, so we'll subtract this from A. So we'll subtract this, this and this from A. So what you get is 1, 3, 5. Similarly for B minus A, what we do is we'll subtract elements which are common in A from B. So the common element is 2, 4, 6. So we'll subtract this from here. So what you get is 8. And we see that A minus B is not equal to B minus C. You're getting what I'm saying? For A minus B, first you write all the elements in A. For example, all the elements in A is 1, 2, 3, 4, 5, 6. The elements which are also in B we'll subtract. 2 is there in B, we'll subtract. 4 is there in B, subtract. 5 is not there. 6 is there in B, subtract. So what you get is 1, 3, 5. This is A minus B. Similarly for B minus A, we'll write first all the set in B. And then we'll subtract all the common elements in A. 1 is there. 1 is there in A. It is there in B. No. 2 is there in A. Is there in B? Yes. Subtract this. 3 is not there. 4 is there. Similarly 6 is there. So we'll subtract this. What you get is 8. This is how we find out A minus B and B minus A. Also we can do the same thing using Venn diagram. In Venn diagram you see this is set A and this is set B. So this guy blue one is A minus B and the red one is B minus A. To represent the same thing in the set diagram, first let's find the common element is 2, 4, 6. So we'll write 2, 4, 6 here. And then the remaining element in A is 1, 3, 5 and here it is 8. So we see A is 1, 3, 5, 2, 4, 6, 1, 3, 5, 2, 4, 6 and B is 8, 2, 4, 6. It is 2, 4, 6, 8. Now the blue one, as I told, is the A minus B. So A minus B should be 1, 3, 5. Answer here we are getting is 1, 3, 5. Same. Similarly for B minus A, the answer should be the one in red area and that is 8. So we see the answer comes same when you use the Venn diagram or we use the normal approach. But the point to note is B minus A is not equal to A minus B. Also one more thing we can note here is whatever set you get here, B minus A, it is A minus B and B minus A, they are mutually disjoint sets. That is, there is no common element. So if you see set 1, 3, 5, this is A minus B and set A, they are mutually disjoint. There is no common element between this A. That is, if you do an intersection of these two sets, this and this blue one and the red one, what you get is 5. We'll do example to clear our concept on disjoint sets. So we have A is 2, 4, 6, 8 and B is 6, 8, 10, 12. We have to find A minus B. So now what we do to find A, we'll do by both approach. First we'll say the normal approach. We'll write A minus B. We'll first write all the elements in A. Yes, since we are doing A minus B. So first all the elements in B, A, and now we'll subtract, see, A minus B. So first write all the elements in A minus, we'll subtract all the elements common between A and B. So now 6, is 6 common? Yes. Is 8 common? Yes. Is 10 common? No. Is 12 common? No. So A minus B is 2, 4. Similarly for B minus A, what we do, you write all the elements in B first. And now we'll subtract the elements which are common, which is there also in A. Is 6 in A? Yes. Is 8 in A? Yes. Is 10 in A? No, we can't subtract. Is 12 and A? No, we can't subtract. So B minus A is 10, 12. Here also if you see A minus B and B minus A are mutually disjoint. That is, we do a intersection of these two sets. So what you get is 5. Now let's do the same thing using Venn diagram. We'll take this big box, rectangle box. We'll create two sets. Before creating two sets, we have to find whether there is a common element between A and B. So we see there is a common element between A and B, that is 6 and 8. That means we have to create circle like this, intersecting circles, and we'll say mention A and B. First we'll write the common element. The common element is 6 and 8. 6 and 8, the common element. 6 and 8. Remaining element 2 and 4 for A will write here, and the remaining element for B 10 and 12 will write here. So this is the Venn diagram representation of set A and B. So we have seen from the earlier graph, A minus B is this whole set of A minus this portion, because this is a common portion. So what is A minus B is this area, correct? So from this graph we see A minus B is equal to 2, 4. And if you see from the earlier explanation what we got, A minus B is 2, 4. Similarly, B minus A is whole set, this set minus common set. So B minus A is this. I'll write in the horizontal lines. So this is B minus A. So B minus A, when we see from the Venn diagram, is nothing but 10, 12. Here also we see in the first process we got 10, 12 answer, and here we are getting 10, 12. Here also we see both the sets are mutually disjoint sets. When you do intersection of these two, you get 5. And also A minus B is not equal to B minus A. So thus the same question we have solved using two methods, and both give the same answer. Now we will discuss complement of set. So if U be the universal set and A is a subset of U, then the complement of set A is all the elements of U which are not element of. When we say A complement, it is all the element of U which are not the element of A. A complement is U minus A. If you see from this U minus A, we can say that complement is nothing but universal set minus A set. So it is nothing but difference of universal set and the set A. We'll take one example. Let's suppose we have universal set from 1 to 10, and we have set A 1, 3, 5, 7, 9, all the even number, odd number. And A complement is this minus this. So first let's do a normal approach, U minus A. For U minus A, we'll first write all the elements in U. 6, 7, 8, 9, 10. And now from this, we'll subtract A. Is 1 in A? Yes. Subtract. Is 2 in A? No. Is 3 in A? Yes. Subtract. Is 4 in A? No. Is 5 in A? Yes, it's here. Subtract. Is 6 in A? No. Is 7 in A? Yes. Subtract. Is 8 in A? No. Is 9 in A? Yes. Subtract. Is 10 in A? No. So what you get is 2, 4, 6, 8, 10. This is nothing but U minus A, and this is A complement, and this is the answer. We can also solve this question using the Venn diagram. Let's create a Venn diagram. Here we have only one set, so let's create one circle A, and we have element 1, 3, 5, 7, 9. Since the universal set had 1 to 10, so we'll write the remaining element inside the universal set. 1 is already captured, so we'll ignore it. 2, 3 is already there, ignore it. 4, 5 is already there, ignore it. 6, 7 is there, so ignore it. 8. So these are the 2, 4, 6, 8, and again 10. These are the elements which are not there in A, so we'll have to write here as the universal set. So when I say A complement is nothing but everything that is outside of A in the box. So we are talking about this. This is A complement. This is the area for A complement. So if you notice clearly, A complement is nothing but 2, 4, 6, 8, 10. Since we got the same answer using Venn diagram and normal approach. So this is the diagram which is there. So if this is A complement is this. Properties of complement. A union A complement is union. So when you do a union between A and A complement, you get a union set. It's true, obviously, because this is all A, this is all U minus A. So when you do a complement union of this, you'll get A. A intersection A complement is phi, obviously, because there is no common element between A and A intersection. Similarly, De Morgan's law holds true. When you say A union B, a whole complement, this is nothing but A complement intersection B complement. Similarly, when you say A complement A intersection B complement, that is nothing but A complement union B complement. That's how De Morgan law is very, very crucial law. Star mark I'll add. Please learn this. A union B complement is equal to A complement intersection B complement. So when you remove the braces, the sign changes from union to intersection and intersection to union. It's a very, very crucial law. A union B complement is equal to A complement intersection B complement, and A intersection B complement is nothing but A complement union B complement. Similarly, there is a double law of complement. So when you complement this object A and then again you complement that, you get, and phi complement is U and U complement is phi. So if there is a no element and you complement that, you get all elements. Correct? That is U. You take all elements, you complement that, you get no element, because complement is subtraction. I hope this are clear. This is a crucial formula which you will be using, so please learn this. A union A complement is U, and A intersection A complement is phi, because there is no common element between A and A intersection. Similarly, De Morgan law, A union B complement is equal to A complement intersection B complement, and A intersection B complement is equal to A intersection union B intersection. Sorry, A complement intersection B complement. And double law of complementation, A complement, again we have to complement on that, that is equal to A. Let's solve one problem on set. So we are asked to find first A complement, where U is this, A is this, and B is this. So A complement is nothing, U minus A. So let's jot down all the element in U first, and from this let's subtract A. A has 2 and 3. So is 2 available here? Yes, cut this. Is 3 available here? Yes, cut this. So this is the final set. 1, 4, 5, 6. This is A complement. Now when we are supposed to write B complement is nothing but U minus B. So again let's write U first. 1, 2, 3, 4, 5, 6. And now B has first element 3. Is 3 here? Yes. Second element 4. Third element 5. Subtract all this. So what you get is 1, 2, 6. That is B complement. This is done. Now we are asked to say A complement intersection B complement. Then we have this now. So we have to write a intersection of this. To write an intersection of this, we have to write all the common elements. So we see the common element in these are, first let me write A intersection B intersection. The common element between these are 1 is common, 4 is here, not here, 5 is here, not here, 6 is here, yes. So 1 and 6 are common element. So A intersection B is 1 intersection 1 comma 6, because 1 and 6 are the only two common element between A intersection and B intersection. Now we are asked to write A union B. For this, let's write A first, 2 and 3, and now we'll write other elements of B which are common. 3 is already there, so we'll ignore this. 4 is not there in this list, so we'll add this. 5 is not there in this list, so we'll add this. So 2, 3, 4, 5 is A union B. Now we are asked to prove that A union B complement is equal to A intersection B, A complement intersection B complement. So first find A union B complement. A union B complement is equal to U minus A union B. So first write U first. U is 1, 2, 3, 4, 5, 6. From this we have to subtract this element. First is 2, subtract 2. Second element is 3, subtract 3. Third element is 4, subtract 4. 5, subtract 5. So what do we get is 1, 6. So A union B complement is equal to 1, 6. And you see that A complement intersection B complement is also equal to 1/6. So both are same. Thus we can say that A complement intersection B complement is equal to A union B